All right, so let's continue with our class. So I said this formula, you have to pay attention to it. It is very paramount to any question you'll be solving on the molar concept, on the stoichiometry. You'll be needing this formula, and it is a very simple formula. Number of mole equals mass over molar mass. I believe by now every one of you should know this formula, isn't it? Number of mole equals mass over molar mass. So if they ask you to find your mass, you simply make your mass the subject of the formula. So mass will be equal to what? Number of mole multiplied by molar mass, isn't it? So it's very simple. And if they ask you to find your molar mass, let's say for example, you first multiply and you make a molar mass the formula. It will be molar mass is equal to mass over number of mole, isn't it? So this is just the basic formula that you'll be needing. Basic formula that you'll be needing as we proceed forward. The other one that I give to you is if they ask you to find the number of particles or number of substance or number of molecules, I said you multiply your Avogadro's constant by your number of mole. This to remember. Suzanne, this to remember. This to remember. I said, let me just write it down for you. The second formula is number of particles, number of molecules, anyone they ask to do is equal to the number of moles multiplied by 6.02 times 10 raised to the power 23. These are the two basic formula, and I asked you to write it down that you'll be using in stoichiometry for molar concepts. I mean for the simple one, before we go to complex questions. So anytime you see questions, probably they give you mass, they ask you to find the number of mole. The only thing you need to do is to find the molar mass of that compound. How do you find the molar mass? By adding the respective atomic mass of that element together. You get your molar mass. For example, if they ask us to find the molar mass of water, the molar mass of water is simply, what is the relative atomic mass of hydrogen? Is it not 1? That will be 1 times 2 plus. What is the relative atomic mass of oxygen? Is it not 16 plus 16? So 1 times 2 plus 16 is equal to 18, isn't it? So this is the relative atomic mass for the molar mass for water. So anytime they give you mass, they have to find the number of mole. Simply firstly find the molar mass. Once you get the molar mass, then you can go back to this formula and say number of mole equals mass over molar mass. Then insert your molar mass and insert the mass that you have been given. Is that clear? It's so simple. So, and in this second part also, if they have to find the number of particles, the first thing you simply need to do is to find the number of mole. In case they don't give you the number of mole, use this formula to get the number of mole. Number of mole equals mass over molar mass. So you find the mass of that compound. They will give you the mass. Use the molar mass, the relative atomic mass of individual atoms, to find the molar mass. Then after getting your number of mole, you will come back to this question and insert the needed parameters to it. Put number of mole there, multiply it by 6.0 times 10 raised to the power 23. Then get a number of particles. It is very, very simple. Today we want to move to kinetic theory of gas and gas law. But before then, I want to be very sure that you guys actually understand what I explained in the last class. So I will just give you some little question. Yeah. So let me start with the question 1. We'll be doing it together. Because yesterday I asked a question on the group and some of you couldn't answer the question. And the question is very, very simple. In fact, I was not expecting you to spend more than some seconds on the question. Look at this question here. They said, what is the number of moles in 11 grams of carbon, and they said the atomic mass of carbon is 12. They get that. So what is the number of moles in 11 grams of carbon? And they said the atomic mass of carbon is 12. It's so simple. Write down the parameters that you have been given. What is the parameter if I give? They give us, they ask us to find the number of moles. So I'm trying. They ask us to find the number of moles. That's what we are looking for. And they gave us the mass of carbon to be 11 grams, isn't it? And give us the atomic mass to be 12 grams per mole. It's very simple. Since it's only carbon atom that is there, the atomic mass is also the same thing as the molar mass, because it is only the element that is present in the reaction. So simply say number of mole is equal to mass over molar mass, or atomic mass, or relative atomic mass, relative molar mass. So with that, the number of mole equals, what is the mass? 11, isn't it? Divided by 12. And that will give you your answer. I believe we all get it. That will give you your answer. Let me check other questions. Please, are we getting it? These things are simple, right? Let me look for one simple questions before we move to complex questions. Look at this. The question says, how many molecules are present in 0.5 mole of oxygen? And the Avogadro's number is 6.02 times 10 raised to the power 23. This is very simple. They want us to get the number of molecules, which is N, right? Capital letter N. So number of molecules is N subscript M, but just write N. Capital letter N is okay. Said are present in 0.5 mole of oxygen gas. So the number of mole there is what? That's 0.5 mole. The number of mole, small n, is 0.5 mole, right? And the Avogadro's number, what is it? The Avogadro's number is 6.02 times 10 raised to the power 23. So it's very simple. You remember the second formula I gave to you? The formula that consists the number of particles or number of molecules, the number of mole, and the Avogadro's constant. Please remember the formula, which is N equals number of mole multiplied by 6.02 times 10 raised to the power 23. So this is what we are looking for. This guy here. We have this guy here. So it's very simple. Then multiply your 6.02, multiply it by 0.5. Then you will get your answer. Is it not simple? Please, are we getting it? Please, are we together? Yeah, it's very simple. So let me give you this last question. All these questions, there should be a bonus question for you in your JAM. Like I said, chemistry is one of the simplest, chemistry, physics, and mathematics. Anything calculation is very simple. Once you understand the formula and the approach, then you will find your way around it. Isn't it? Okay, so let me continue. This question says, what mass of sodium chloride is present in 2 moles? And they gave us Na atomic mass to be 23, chlorine to be 35.5. Come on. All the students do this for me. Every one of you do this. They give you a number of mole. They've given you atomic mass. Use your atomic mass to find your molar mass. Then find your mass. Everybody, type your answer. Let me see. I'm waiting. This should not take you more than 30 seconds. Gift, Suzanne, Akinwale, B, Titilola, 117 gram. Okay. Gift B. Okay. We have two people already. How about others? Chioma, is it now they are starting the class? If I catch you, don't you know today's class is 10 a.m.? You have been where? You have been in the class since 15 minutes ago. Ah, that's an issue from your side, though. You started the class since hey, yeah, sorry. We've not done much. We can check the video after the class. So please, all only gift and Titi Lola has answered me. Oh. Others, please type your answers. Eh, this question should not take more than 20 seconds. What's the issue? You guys are not making me proud, though. Hello, I'm still waiting. If you don't know it, signify. Or why are you not typing? Hello? I should explain another example. Are you not getting it? I've explained like 4 examples. Suzanne, what's your answer? Suzanne, what's your answer? Eze, what's your answer? Akinwale, what's your answer? Suzanne, unmute your mic and talk to me. Hello, what's wrong? Are you guys not hearing me? Answer me now. You are giving me thumb up. I don't need your thumb up. Oh. Answer my question, Joe. These things are simple. What's the issue? Now, we've not moved to complex issue in chemistry. We are still in the peripheral level, and you guys are finding it difficult. Look at the question. The question says, what mass of sodium chloride is present in 2 moles? What is the number of mole that we have there? The number of mole is 2 moles, right? And they have also find the mass of sodium chloride. 4.0348. It's not even in the option, is it? How do you get that? We are looking for the mass, and we need to get the molar mass. Remember, there's a formula that says number of mole equals mass over molar mass. Now, we have our number of mole. They ask us to get the mass. We don't know the molar mass. So how do we get the molar mass? By adding individual relative atomic mass. Is that not what I told you guys? The molar mass of NaCl. Look at the compound. And they give us Na to be what? To be 23, right? Oh, that's my system manual. They give us Na to be 23, right? Isn't it? What is the best atomic mass for chlorine? It's not at 5.5. That's 23 loss at 5.5. So what is 23 plus 35.5? That should be 15.5, I mean. So my system is hanging again. That's 58.5 gram per mole. Do we get that? Please, do we get that? So now that we have gotten now, our molar mass is 2, right? Our number of moles is 2. Our mass is what we are looking for. Our molar mass is 15.5. So if we first multiply, if number of moles is 2, mass is what we are looking for, and the molar mass is 58.5. It simply means our mass is equal to 2 multiplied by 58.5, isn't it? What is 2 multiplied by 58.5? That will give you your answer. I think that should be 117. Please, do we all get that? Do we all get that? Eze, Akinwale, Suzanne. Okay. It's very simple now. I don't know why you guys are not getting these things. You made a mistake. Okay, now. Akinwale, do you get it? Oh, please don't make mistake in your Jambo. This topic is competitive. Competitive, like, who are you competing with? Topic is not competitive. Oh. What do you mean it is complex? This is the simplest topic in chemistry. It's confusing. It's not confusing. I don't like making it to be confusing. No. It's a very simple topic. If I see any question on all these things in my Jamba, when I was in your age, I can't use 15 seconds to solve it. I'm telling you, I can't use 15 seconds. Stoichiometry molar concepts. I can't use 15 seconds. It's the simplest. In calculation wise, stoichiometry is the simplest. It's just number of mole equals mass over molar mass. Number of particle equals number of moles multiplied by Avogadro's number. What's not the difficult thing there? Just two formula. You cannot apply it. What if you are talking about 10 formulas, 15 formulas in one topic? Where I catch you, eh? Yeah, you guys should do this one. How many atoms are present in 1.5 mole of hydrogen atoms? Very simple. Tell me the answer. Okay, you said A. Okay, that's good. Any other person? Titi Lola, Michael. What was your answer? Akinwale Eze, Suzanne, Miss Competitive. Papa, Titi Lola A. Okay, what about that? Okay, said A, Titi Lola said A. Eze A. We have three people. Suzanne, I'm waiting for you. Akinwale. Okay, A. So it means Suzanne. Suzanne, we are waiting. Oh, A. Confidence, welcome. So solve the question also. If some of you are saying A because some people say A, if I enter your throat, you said how many atoms are present in 1.5 mole of hydrogen atoms? So they gave us number of mole to be 1.5, right? They asked us to find how many atoms. I said when you hear the word, the number of atoms, the number of molecules, the number of substances, which formula are you to use? You use number of atoms equals number of mole times Avogadro's number. Is you know it means N equals number of mole times Avogadro's number. So this is what we are looking for. And we have this one already. Very simple. Then you multiply, that will be 1.5, then 6.02, then 10 raised to power 23. This I have to start my screen. So that will give you your answer. I think that should be A. Confidence. Are you with us? So let me give you more standard question. You guys should do it. After this one, let's go to the topic we have for today. By now, you should be able to answer stoichiometry. Let me look for better question for you. So you guys will give me like 1 minute. I want to restart my screen. Just write the question down so that I can start this screen. How do we get our answer if we use calculator? You simply multiply 1.5 multiplied by 6.02 times 10 to the power 23. The calculator will give you now. What do you mean, Susan?
So actually, some calculators don't usually do 10 raised power 23 like
Okay, the
that. That's
calculator
why
you'll
I'm
be using
saying.
is on the system, Abby. A system calculator.
Okay.
I don't know how Jump does their Jump now, but then we use calculators on the system. So once you just press, there's a calculator on your taskbar. Go and check it. Once you click it, so if you want to multiply this, you don't need to add 10 to the power 23 to it. Just type 1.5 times 6. Since it's the same decimal, so it won't affect your 10 to the power 23. Then what you get will be your answer. So have you written this question down? I want to restart my screen, please.
Not yet, sir. I'm still writing.
Okay, write it so that I can restart. So you guys can do it, and when I come back in the next 1 minute, you can tell me what you get. Titilola, what's your answer? Gift, what's your answer? Akinwale, confidence. Suzanne, easy. Are you guys done writing? 4 modes. That's Titilola. Gift 4 modes. Now, what if they ask you to find uh, the mass of oxygen? Okay. Only 4 modes. What if they ask to find the mass of oxygen? What will be your answer? You know what you get is number of mole. What if they ask to find the mass after getting the number of mole for oxygen? Anybody? Please, are you all getting it? I believe Gift is getting it. I think Titila likes Akinwale. Let's see what's the answer. I think Akinwale has answered it, right? Confidence. Alpha now. Suzanne Alpha. Yeah, for those that have gotten the mole, use that mole to calculate your mass for oxygen. O2. What will be your answer? 128 gram. Number of mole equals mass over molar mass. The number of mole is 4. The mass we are looking for. The molar mass of oxygen is 16 times 2. That's 32. That's 32 times 4. 32 times 4 is your answer. Is that what you get? Let me check. You got it. Suzanne, are you with us? Confidence, I'm not seeing you're working, so please, I want us to move together. I want us to move together. What if they ask us to find the mass for methane? We have the number of moles of methane to be true. They ask us to find the mass. So find the mass of methane. Everybody, do that! The mass of methane. Very fast. 32. The mass of methane, 32. Number of mole equals mass of molar mass. So let me see the answer first. Let everybody do it. It's also somewhere. Easy 96 gives 304. 32. $30 304. You know, why guy gets getting different thing? Hey, wait. Chineke. That's okay. I don't even know the answer. Let's quickly do it together. It's able to find the number of mass, the mass for methane. What's the molar mass of methane? It's very simple now. CH4. Sorry, my system is hanging. I won't be able to write effectively. CH4. Carbon is 12. Hydrogen is 4. Is that not 16? Eh? A number of molecules mass of molar mass. That's 2, 10, 16 now. The answer to be 32. Who got 32 here? Who got 32? Let me check. Titi Lola, you missed this one. No. Titi Lola, what happened? Akinwale got it. Gift got it. AZ 96. How come AZ? Where do you get it from? Titi Lola, what happened? Made a mistake. I thought I was okay. I know I said methane, CH4. I believe by now, Suzanne, you are not talking though. Suzanne, Grace, you are not talking though. Easy, where do you get it from? That is because of the molar mass of methane. Don't you get the CH4O2? How come now? Look at the formula now. Look at the equation. The reaction says CH4 plus 3O2. Methane is CH4 now. That's the first organic compound in the alkane. Is it the first? Yeah, the first. So the CH4. These questions I just had. What should I do now? Wow. Suzanne, this is the easiest question. I bet it with you. I'm telling you, these are the easiest questions. What can I do for Suzanne like this? Who understand? You try to solve it yourself, but you're not getting it. Who understand this topic very well out of you guys? Give the high very well. Titi Lola, you understand it very well. You understand it very well. Okay. I will give you like 5 questions. Will you? It's not hard, but to understand the question first is a little bit hard. The questions are direct. The questions are direct. I'm very serious. Okay, let me look for a question. I actually want us to move to another topic, but the way you guys are talking now, it's as if you are still not getting it very well. I don't like rushing topics. I want you to understand it. It's so simple. Uh, let me just give you a question. My system is angry. Let's say hydrogen react with oxygen to give water. So how do you balance this one? Isn't it? So they asked us to find, say the number of mole. If me having a except because I've been cracking out to understand it. It's simple. Titi Lola, you and Suzanne, I pair you guys together. You are now friends from now on. Say amen. So this is what will happen. After the class, you guys should exchange digits. What they call. I will call you guys tomorrow, the two of you. I will be on call with you tomorrow. If Susan did not know you before tomorrow, the two of you, Stella, do you hear me? Uh-huh. The two of you should exchange digits. Message yourself, explain to her. Maybe if student expect to student, maybe you know it better. Number of mole for let me say oxygen. Let's say they gave us 2 moles. Sorry, my system is very slow. That's why I want to restart my system. It's very, very slow. They now ask us to find the mass of hydrogen. This is a very technical question, but it's very simple. And these are exam will be asking you. So quickly write this thing down. I want to restart my system. I'm not enjoying. Find the mass of oxygen, the mass of hydrogen. Please, do you all understand the question? Do you all understood the question? I want to, and can you guys write it down? So they give us this formula, this reaction, 2H2 plus O2 giving us 2H2. They now give us number of mole of oxygen to be 2 moles. I said 2 moles for number of mole of oxygen. They asked us to find the mass of hydrogen. So here, you should be able to know that you need your molar ratio to get the number of mole of hydrogen. But I said it's very technical. What is the molar ratio between hydrogen and oxygen? Once you understand it, use that molar ratio to get the number of mole for hydrogen. Then after getting the number of mole of hydrogen, use number of mole equals mass per molar mass to get the mass of hydrogen. So simple. I believe you guys are fitting it already. I want to restart my system, please. Has it been written down? Okay, give me some minutes. Let me. Okay. So quickly do that as I join you guys in 1 minute. Yeah, I'm back. Sorry for that break. So, are you guys done? Let me share my screen again. Almost. Okay, Titilola. I believe you guys can see my screen, right? Okay. So, all right. Sorry, pardon me. The mass H2 is the mass is the mole. Please, do you all get the question? I have to find the mass. Still alive, find the mass. Gift, the mass. Easy. Easy said 8 gram, I mean. Confidence, half an hour. Akinwale, Suzanne, I'm going to know 8 gram. Okay. What about that? Gifts, Suzanne, you're not talking. Confidence, what happened? You're not talking. I look at the question. They said 2H2 plus O2, right? Given 2H2. So what's the molar ratio here? 2 ratio 1 ratio 2. Do we all get that? That is the molar ratio, isn't it? So it simply means the ratio of hydrogen and water are the same. That means the number of mole of hydrogen is the same as the number of mole of water. So let's assume now that they ask you to find the number of mole of water. The number of mole of water will also be 2 moles. Are we together? Because they are 2 ratio 2. Please, do you get that point? But now look at hydrogen to oxygen. Hydrogen has a molar ratio of 2, a mole of 2. why oxygen has 1. It simply means hydrogen is 2 times greater than oxygen. So the number of mole of oxygen is 2 mole. It simply means if hydrogen is 2 times greater than oxygen, therefore the number of mole of hydrogen will be 2 times 2, which is 4. Please, do we all get that? Do we all get that aspect too? Please, I need your response. So we have 4 moles because of the molar ratio. That's 2:1. Let's assume the ratio is 3:1. All together, it will be multiplied by 3. Let's assume it is 4:1. It will be multiplied by 4. Exactly. So the number of mole of hydrogen is 4 moles. Then now has to find the mass of hydrogen. Now that we know the number of mole of hydrogen, and they have to find the mass of hydrogen. So check the formula here. The hydrogen is H2. That's 1 times 2 will give us the molar mass. So the molar mass of hydrogen is 2, right? So the number of mole equals mass over molar mass, isn't it? And the number of mole is equal to 4. The mass is what we are looking for. The molar mass is 2. If we cross multiply, our x equals 8, which means our mass is 8. Please, do you all get that?
Sorry, I was asked to get definition.
Yeah, month is very low because of somebody
Please,
saying
guys,
my
give me like a minute. I'm coming. I'm trying to attend to something now. Is that okay?
okay.
Sorry for that. Okay, do you all understand how we get the mass now? So I believe by now we should proceed with the other things we have for today. Please, are we on the same page? Please, I need your responses. Yes, sir. Thank you. Okay, so let's move to kinetic theory of matter and gas law. That's the topic for today. Can you please write it down? This is chapter 3. This is the third chapter that JAMB asks you to know for this year chemistry JAMB exam. The kinetic theory of matter and gas law. We'll be talking about different law. We'll be talking about Boyle's law, Charles law, Avogadro's law, and all of those laws. No. So, kinetic theory of gas, it explains how the behavior of matter are based on the motion particles. That is what kinetic theory of gas explains. It explains how matter behaviors are based on the motion of particles. So there are some core things that you need to understand, which is the main idea that you need to understand under kinetic theory of matter. It's that matter is made up of tiny particles. Let me just copy it for you. And matters, they are always in motion. And you need temperature in order to enhance collision or motion of particles. Let me just write it down so that you can quickly write it. These are the four things that you need to pay attention to under kinetic theory of gas. You need to understand that collision between gas particles and elastics, and collisions occur when there is an increase in temperature. Is that taken? So those are the main ideas that you need to understand on kinetic theory. Another thing you need to understand that they can ask is how particles are arranged. How particles are arranged and their motion. We have different type of states. We have the solid state, we have the liquid state, we have the gaseous state. So they can test you and ask you, what is the particle arrangement of a liquid state? What is the particle arrangement of a solid state? What is the particle arrangement of a gaseous state? And how do they behave in motion? Do they slide over each other? Do they vibrate? Do they move freely? So let me just quickly copy that for you. So I can quickly write that. So that's particle states and their motion. Before we move into gas law, which is the most important thing. So under this kinetic theory, like I said, the whole things they can ask is either they can ask you that for molecules that are slightly apart, what is the kind of state such molecule can have? So when we talk about slightly apart, it talks about liquid. Or if they say that a molecule that takes the shape of its container is what? Is also liquid. Are you okay? It's also liquid. And if they ask you that uh, particles that has haphazard movement or has free movement in air, that one is gas. All that is taken. And there's one other key point that you need to take note of. You need to pay attention to is the kinetic energy in this state. The kinetic energy in this state. Methane has an increase in kinetic energy. Do you know when we say something is melting? What does it mean when we say something is melting?
When a substance changes from its liquid state with solid state to liquid state, the application of it.
Very good. From solid state to liquid state. When the temperature is applied and it changes from solid to liquid, like ice. This one, like I was saying, increase in kinetic energy. Please pay attention to this. This is jump angle. What did I say? This is jump angle. They can ask you sensitive question on this. They can ask you that a substance F changes its state from solid to liquid. Please, are you with me? They can ask you what has happened to the kinetic energy. A, the same kinetic energy, or does not change, or unchanged. B, decrease. C, increase. And you can say D, irregular. Please, do you get it? So you should pay attention to this angle a lot. So anytime you hear methane is talking about there's increase in kinetic energy. Please, are we together? So it simply means they can use change of state from solid to liquid to ask the question. They can just say melting. Please, are we together? So, You want to talk again? Why you guys doing? Suzanne, Akinwale. Okay, so for the freezing, instead of increase in kinetic energy, there is decrease in kinetic energy. Decrease in kinetic energy. Is that faking? So you know what freezing is. Akinwale, what is freezing? From what state to what state does it change? Akinwale,
From liquid to solid.
freezing from liquid to solid. Thank you. Liquid to solid. So anytime they ask you a question, please pay attention to this side. They can ask that a substance changes state from liquid to solid. And they can say that they can just write water and they put liquid here. I do water and they put solid here. And they ask you that what has happened to the kinetic energy? What has happened to the kinetic energy? Please, do you get the idea of everything? So looking at this, you know that, oh, this is liquid. This is solid. So it has changed from liquid to solid, right? So therefore, it is freezing. So that means there will be decrease in kinetic energy. Do you all get that? Do you all get that? Yeah. Another one is boiling. Easy, what is boiling? From one state to another state. Easy, what is boiling? From what state to what state? Titilola, can you bear him? Titilola, Suzanne, can you bear them? No one is talking,
Yeah,
Abby.
it's from liquid state to gaseous state.
All right, thank you. From liquid state to gaseous state. Easy, you're not serious. So I asked you to talk, you are doing thumb up.
So take the comment section because I'm using the comment section as in the message section to answer the question. So that's
I
it.
can't see the comment section for now. That's the issue. I can't see your comment section. Okay, so let's move to gas law. So when it talks about gas law, it explains the relationship between pressure. Please, I want you to pay attention to this aspect. It explains the relation between pressure. It explains the relationship between pressure, temperature, volume. So that's what gas law talks about. But we have different gas law. Example of gas law. Some of them just explain the relationship between pressure and temperature. Some explain the relationship between pressure and volume. And why some explain the relationship between the theory. Is that taken? So let's start with the first one, which is Boyle's law. So Boyle's law states that at constant temperature, the volume of a fixed gas is inversely proportional to its pressure. Said the volume of a fixed mass of a gas is inversely proportional to its pressure at constant temperature. It states that the volume of a fixed mass of a gas, I hope you guys are jotting, is inversely proportional to its pressure at a constant temperature. So looking at the Boyle's law, it says the volume of a fixed mass of a gas, let's say V represents our volume, that is inversely proportional. Inversely means 1 over to its pressure. So it's inversely to its pressure. Is that taken? So this is the mathematical illustration of that theoretical definition that says volume is inversely proportional to its pressure. So if you want to turn this thing to an equation, it will be V equals to K over P. The K simply means the constant, right? Isn't it? So if we make our constant the shade of the formula, that means PV equals constant. So it simply means our P1, V1 is constant as P2, V2. Please, is that taken? Please, do we all get this? Please, do we all get this? So where P is equal to pressure, right? The pressure 1, V1 is equal to volume 1, P2 is equal to pressure 2, and V2 is equal to volume 2. So anyone they ask you to do, you can simply make one the result of the formula, isn't it? So Titi Lola, make P1 the result of the formula. Make V1 the result of the formula.
Sorry, sir. Should we say, since you said you can't see the comment section for now?
Don't worry, I can see the comment section now. I have come back to it. But if you want to say it, it is okay. So easy, make P2 the result of the formula. Suzanne, make V2 the result of the formula. So in these cases, if they have to find your P1, okay, Titi said P1 equals P2 V2 over V1. That's very correct. The second person, what's your V1? Who is the second person that I called? You guys want to scatter my head. I will remember Suzanne is V2. Eze is P2. Who is V1?
Sir, what did I say?
Eh?
What did you say? What did you say, sir?
Fine, make V2 the subject of the formula, V2 in your Boy's law equation.
Okay.
Eze P2. Who is V1? Is it gift or confidence? Okay, P1. So let me pick another. So you said P2 is equal to P1 V1 over V2. Is that correct? P1 V1 over V2. Yeah, that's correct. So that's just how to apply Boy's law. So Suzanne V2. Akinwale do V1. After this, we do Charles law. Then we end the class. So next week we will check questions under Boy's law and Charles law.
Sir, it's got
Who is talking?
V is me V2 is equal to
V2 is equal
it's
to
equal P1 over V1.
P1 over V1.
Sorry, P1 V1 over P2.
Become you said V2 is equal to come again.
P2 is equal to P1.
P1
Yes. V1
V1
over P2.
over P2. Very good. Let me check. V2 equals P1 over P2. Very good. So the last person for V1, Akinwale. Akinwale o. Maybe you are just joining us.
Yes, sir.
Why do you came late?
I was trying to join earlier, but it was not connecting. I just joined now. So I was just able to connect now.
So okay, that's too late. Just go back and visit the recorded video on your dashboard for today's class after the class.
Okay.
So make V1 the subject of the formula for Boy's law. That's your first welcoming. We are welcoming you to do that.
That's P2V2 over P1.
P2 V2 over P1.
P1.
Very good. Akinwale, if I get you, sincerely, I told you I'm a Spider-Man. I will spider your head. I called you to answer me. You don't answer me. I will spider your head. So let's move on. Let's quickly go to Charles law. I believe you understand what Boy's law talks about. So Boy's law is just a relationship between pressure and volume, but their relationship is inversely related. Like one person on the top, other thing downward. Inverse relation. Sorry, my system is hanging again. Yeah. You are using our hand to cover your face. Don't worry. We will see behind the scene. So let's go back to our Charles law. So quickly write the Charles law, definition. And in case they ask you, the relation between period and volume is rectangular hyperbola. Rectangular hyperbola. In case they ask you, is rectangular hyperbola. JAMB asks these questions. You can ask it the graph, the graph period volume relation that Boyle's law is rectangular hyperbola. Is that taken? So we consider, okay, before then, you guys should do this. For next week, we will consider better questions. Check your past JAMB questions on. Please, everybody do that and tell me the answer. I believe you should know that now. So let's move to Charles law. Once you get the answer, drop your answer. So this is the okay. Someone asked a question. Rectangular hyperbola. Let me show you the graph. Let me show you the graph of it's just how the graph of how the graph of Boyle's law and of period and volume of Boyle's law looks like. Maybe I will try to get to the. So you kindly do that question. So the graph of Boyle's law, when you check it on the graph, it has this hyperbola. I will help you look for the graph ahead of the next class so that you can see it. I just want to use this one to explain a concept for you. Look at it. The higher the volume, the smaller the period, because the volume will occupy more space. You can see, look at the period radar. You can see it's very small when the volume is very high. Look at it when the volume is very small here. You can see the period has increased, right? So that's the relation between volume and period in Boyle's law. As the volume is increasing, the period is decreasing. And as the volume is decreasing, the period is increasing. Hope that is taken. So the graph relationship between period and volume for Boyle's law is hyperbola, rectangular hyperbola. I will show you a graph later on. I'm trying to look for it, but I can't get it at the moment. As I said, 100 centimeter cube. What about others? Maybe Alpha. What's your answer?
I'm pissed off,
Titilola.
sir.
Okay, Titilola. Suzanne. Competitive. Give to Alpha now. Eze. Akinwale. You guys shall still remember the formula. All these things should not be taking more than 5 seconds. Still solving. You are using 2 minutes, I'll be 5 minutes to solve Boyle's law. You are saying which question? A gas occupies 200 centimeter cube at 100 pressure. What volume will it occupy at 200? What is your P1? What is your P1? 100 centimeter cube. You still remember the formula now? Just write the formula and insert the appropriate parameters there. I'm expecting answers from everybody. Gives 100 centimeter. That unit is not correct, so centimeter cube. In case you say 100 centimeter.
I do.
100 centimeter cube. Okay. So I think all of you got it. So let me check so that I can be sure. It will not be that all of you are doing all this. A gas occupied 200 centimeter cube. The V1 is 200. The P1 is 100. The V2 we are looking for it. The P2 is 200. That's P1 V1 equals P2 V2. Okay. So P1 V1. That's 200 times 100 divided by 200. That's 20,000 divided by 200. Okay, you guys are right. So shall clap for yourself, baby. So quickly go to Charles law. We'll do more past questions on Boyle's law in the next class. So let's quickly go to Charles law. So Charles law states that the volume of a gas is directly proportional to its temperature. So looking at this, it said the volume is directly proportional to its temperature. That's V directly proportional to T, right? That's V. Sorry. That's V directly proportional to T. So you can see that the relationship between volume and temperature here is a direct proportionate relationship. So as the volume increases, definitely the temperature will increase, isn't it? So if you want to turn this to a mathematical expression, that V equals KT, right? So if you make H from that would be V over T. That's V1 over T1 equals V2 over T2. That's for so I believe every one of you can make any one out of these four parameters, the subject of the formula. Am I saying the truth? I hope so, right? Every one of you can make any one of the parameters the subject of the formula, isn't it? If that is it. Anytime you are dealing with temperature in gas law, always make sure that the temperature is converted to Kelvin. What did I say? Always make sure. JAMB will always give you the temperature in centigrade. Please don't be in too hurry. don't be too hurry. Don't be in hurry to use your centigrade, your Celsius degree of your temperature. Convert it to Kelvin. So if you want to convert it to Kelvin, you add 273 to it. Is that not it? So if they give you 27, for example, if you add 273 to it, it will give you 300. If they give you 10, you add 273 to it to give you 23. Right? So that's it. So let's do this question together. Because one of the mistakes, if you use centigrade, funny how you will see the option, you will see that answer in your option. Because JAMB knows that many of you, you don't be too patient. You'll be rushing. Like is it not Susan that like eating? If you want to go and finish, let me finish my exam. I want to go and eat Indomie at home. And she will just use centigrade. And she'll be thinking, oh, I've gotten it. Oh, I've gotten it. So quickly do this. A gas has a volume of 300 centimeter cube at 27 degrees. So find its volume at 27 degrees. All of you, that's solve it. What's the answer? Spider-Man, Spider-Man. Spider-Man. What's the answer? Okay, you guys are.
Wait,
Let me check it.
are we going to convert the temperature to Kelvin before we solve?
Oh, you want to keep me with that question? Who is that? What's that?
It's gifts.
Gifty. I just said it now that any temperature that you have been given, convert it to Kelvin. Now you're asking me, will you convert centigrade to Kelvin? What should I do for you? Just tell me.
I was not paying attention. Let me solve.
You not pay attention. What are you doing? You are watching Korean film. Eh?
No,
You
I'm
can't see the message. Akinwale, why are you having issues in the screen? You have to solve your phone issue. Everybody is seeing the screen. You complains that you don't see screen, don't see screen. It should be an issue from your side.
I'm not having issue seeing the screen. No. Maybe someone else that sent the message.
I mean, easy. Yeah, the question is on the screen now. A gas has a volume of 300 centimeter cube at 27 degrees C. Find its volume at 127 degrees C. Okay. Princess got 400. We have princess in the group, Princess Mary. We don't have queen. And we don't have king. Akinwale, you are king. Akinwale. Akin is always, they are warriors. You are not king. Princess Mary got 400. Akinwale got 400. Titilola, 400. Gift got 400. So that means 400 is the answer. Yeah. So next class, we will go into other laws. Then we will check at least 15 past questions on the topics together. So we'll be doing it one after the other. So do you have any questions so far? Eze, do you now see the screen? Were you able to see the screen? Yeah, you're still not seeing it. Yeah? Waiting now. So ahead of next class, please, you guys should read combined gas law. What did I say? Read combined gas law ahead of next class. An ideal gas equation. These are the two law that we'll be checking. Combined gas law and ideal gas equation. An ideal gas equation. Is that the combined gas law and ideal gas equation? Do you have anybody with any questions so far? Go and watch, the previous. Like I said, one was the recordings on move concepts and psychometry on the If you have any question, do well to use your group. I mean your WhatsApp group. Ask questions, top questions on chemistry. I'll be dropping some questions on jazz law, voice law tonight. So you guys should attempt it as fast as possible. And to Princess that is also joining for the first time, do well to check your dashboard. You will see previous recordings on different topics, about 3 or 4. Please do well to check it so that you can get familiar to the things we've checked so far. Is that taken? So you guys should do well to stay committed to your learning. After the class, there's always a learning to do in order to ensure you get what you need to get, and that is reading your notes. Please, after the class, go and read your notes, check it again. If there's anything that is not clear, in the next class, you ask questions. Is that taken? So please and please do that. I believe we've come to the end of today's class. And Susan and Titilola, I've connected you guys together. You guys are not, you're not friends. So Susan and Titilola message each other. Find a time you guys can discuss psychometry. In the next class, that is next week, Monday, right? I will be having chemistry. No, next week, Tuesday. By then, you guys must be able to meet, and Susan must be proud to say, I now know more concept and psychometry very well. Is that taken? So let's do well to enjoy the rest of our day. You guys should take good care of yourself. I love you guys. You will see the videos for this class in your dashboard after the class also. So gifts. Bye-bye, Suzanne. Bye-bye, Easy. Titilola. Princess. Princess. Bye-bye. Akinwade. Bye-bye. Take care now. Bye-bye. Yeah, same here. See you. We meet on Sunday. So let us meet on Sunday so that you can ask questions. You can ask me medical questions on Sunday, sure. Bye-bye.